Welcome to today's lesson on solving for unknown angles using auxiliary lines. Our learning targets: I can define an auxiliary line. I can draw auxiliary lines in diagrams to create parallel lines cut by a transversal and then solve for unknown angles. And I can apply the theorem that says the measures of the interior angles of a triangle sum to 180 and then solve for missing angles in triangles. So we're going to start with some review. And you have to recall the pairs of angles formed when you have parallel lines cut by a transversal. So the first question says, what is the measure of angle ABC? So if you're not sure where ABC is, you should trace it. You can use your highlighter. That's this entire angle right here. Now, where many students go wrong is they think that this line is bisecting this angle, when in fact it's not. So we can't assume that this top portion of the angle is equal to the measure of the bottom portion of the angle. So we're going to start with the top two parallel lines. How do we know they're parallel? Because we have the arrows to denote that they're parallel lines. And then we have this transversal right here. So let's start with alternate interior. If you recall, alternate interior angles are equal. So this is alternate interior with this, and alternate interior angles are equal. So if the top is 75, this bottom portion is also 75. Now I'm going to look at the bottom two parallel lines. Again, I know they're parallel because there's arrows located on the lines. Here's the transversal. Again, I'm going to look at alternate interior. So I have the 45, that's alternate interior with this guy right here, the top portion. So that also has to be 45. And in order to find the entire measure of angle ABC, what we're going to do is we're going to add those two parts together. So 75 and 45 gives us 120. So the measure of angle ABC equals 120. Down to example 2. This one's a little bit trickier. It says the measure of angle 1 is 16x minus 8, so you can mark that off if you would like. And 2 is 4 times y plus 8. 3 is 14x plus 2. They want us to find both x and y. And notice that we have two pairs or two sets of parallel lines. We have the top and bottom, and then we have the left and the right being parallel to each other. The reason that I have one arrow and one arrow is to tell us that the top and bottom are parallel. And then I have two arrows on each of these guys is to let us know that the left and the right are parallel to each other. So we're going to start again with, we can start with the top and the bottom. And then we have this transversal located right here. If you recall, angles 1 and 3 are known as corresponding angles. Well, corresponding angles are equal to each other. So if we set these two equal to each other, we would be able to solve for x. So 16x minus 8 equals 14x plus 2. I'm going to subtract the 14x. So 2x minus 8 equals 2. I'm going to add the 8. So 2x equals 10, divide by 2, x is 5. Now, I still have to solve for my y value. So if you look up here, we have a y value as the measure of angle 2. Now, if we were to take this value and substitute it back in, doesn't matter which one we substitute it back into, because remember, corresponding angles are equal. We can find the measure of one of these angles, which will hopefully eventually help us find the measure of this angle over here. So I'm going to start with 14x plus 2. So 14 times 5 plus 2. 14 and 5 is 70, plus 2 equals 72. So this angle at 3 right here is 72 degrees. Now, how can that help us? Well, if you look, we have another pair of, we'll look at the parallel lines we were just talking about, the top and the bottom, and this transversal. we can mark off alternate interior. So if this guy is 72, then this guy also has to be 72. Alternate interior angles are equal. Now we have this pair of parallel lines, and then we have this transversal. And if you look at the measure of angle 2, which is 4 times y plus 8, 2 and where the 72 is, these are corresponding again. And what did we just say about corresponding angles? That they're equal. So we're going to set this equal to this, and we're going to solve for y. So 4 times y plus 8 equals 72. We're going to apply the distributive property. So 4 times y is 4y, 4 times 8 is 32. I'm going to subtract the 32. 4y equals 40, and I'm going to divide by the 4. That's going to give us the value of y, which in fact is 10. So I've solved both for x and I've solved for y, and I'm finished. I'm going to turn the page. Okay, we don't have to recopy the learning targets. We've already copied them on the front. We're going to actually define what an auxiliary line is here. So we're going to fill in the definition. An auxiliary line. It's a line, a segment, or array that can be drawn in a diagram to solve a problem. So over in your diagram, if you look, we're going to draw an auxiliary line. An auxiliary line should be dotted or it should be dashed to indicate that it's not one of the original lines. So make sure that you know when you draw in your auxiliary, it must be a dotted or a dashed line. That tells us that in fact it was not part of the original problem. We've added that in to help us. So down to the exercises, it says, use auxiliary lines to find the unknown labeled angles and show all work. So where would I place an auxiliary line in this problem? I have the 2 parallel lines, and given the fact that line L is parallel to line M, we're going to find the measure of angle A, which is located right here. So to draw our auxiliary line, we're going to take our ruler or a straight edge. Remember, it has to be dotted or dashed. Now, recall that when you create an auxiliary line, it doesn't necessarily bisect this angle. So it doesn't mean that this top portion of A is equal to the bottom portion of A. So we're going to follow basically the same process that we did on the front page. And now we have 3 parallel lines, so you can put an arrow on the auxiliary to denote that it's parallel to the other 2. We're going to start with alternate interior. So if you look at the top 2 parallel lines, you have 47 here. It's alternate interior with this guy, so that has to be 47. And look at the bottom 2 parallel lines in this transversal. We have another pair of alternate interior. So if this is 133, then we would know in fact that, we can't do alternate interior with this because we would need this guy and this guy. So what we're going to have to do here is angles on a line. 2 angles on a line are supplementary, which means in fact that they add up to 180. So if you take your calculator and you do 180 minus 133, you're going to get 47. So this guy's 47. Now, if this is 47, it's alternate interior with this guy. Alternate interior are equal. So if that's 47, this is also 47. And in this case, the auxiliary line did bisect angle A, but remember, That's not necessarily the case in these problems. It doesn't mean that the auxiliary bisects the angle. It could, but it doesn't necessarily have to. So we want the entire measure of angle A. So what we're going to do is we're going to add the 47 and the 47. That's 14, and that's going to be 94. So the measure of angle A is 94 degrees. Okay, over to example 2. It says, given line L is parallel to line M, find the measure of angle A. And if you notice, the parallel is not marked off this time, so we're going to add our arrows to denote parallel lines. We're going to add our auxiliary line by using our straight edge. Now, instead of finding the angle on the left-hand side, this was A last time, it's going to be the angle on the right-hand side. So we're going to follow a similar process. Let's start with vertical angles. So I have a pair of intersecting lines down here. And we know that vertical angles are formed by intersecting lines, and vertical angles are equal. So if this is 58, this guy also has to be 58. Now, if we look at, and we can add an arrow here because we know all three lines, in fact, are parallel. If we look at the auxiliary line and the bottom line, we have a pair of alternate interior, 58. This would also be 58, but we need this portion over here. So remember, same side interior angles, which would be the 58 and the bottom portion of A, are supplementary. So to find this bottom portion of A, we're going to do 180 minus 58. That's going to give us 122. So I'm going to put the 122 right here. Okay, let's see where we can go next. We can look at the top two parallel lines. Now, we have a pair of corresponding angles. So we have this upper angle corresponding with this top portion of A. And what do you know about corresponding angles? Well, we know in fact that corresponding angles are equal. So if this is 162, this also has to be 162. Now, if we want to find the entire measure of angle A, we're going to add up those two parts, 162 plus 122. And we're going to get 284. So the measure of angle A this time is 284 degrees. Okay, you are going to do number 3 on your own, and what you're going to solve for is the measure of angle 2, which is located down here. And when you're finished, you should get measure of angle 2 equals 37 degrees. Okay, let's turn the page. The second part of our lesson today is talking about the sum of the interior angles of a triangle. Now remember, if you were to add up the measures of the three angles inside the triangle, angle A plus the measure of angle B plus the measure of angle C, they would add up to 180. So measure of angle A plus measure of angle B plus measure of angle C equals 180. We're going to use that fact to help us solve the problems below, starting with exercise 1. It says find the measure of the missing labeled angles. Well, the missing labeled angle here is 1, so we have to find this guy. Now, we can start with angles on a line down here. We have 78, and we have the angle right next to it on the same straight line. So to find this missing angle, we're going to do 180 minus 78. That's going to give us 102. Now remember, from our theorem, if you were to add up all three angles in the triangle, they should add up to 180. So we're going to add up 102 and 42, and that's going to give us 144. We're going to subtract that from 180, and that will give us 36 degrees. So the measure of angle 1 is 36 degrees. Okay, over to problem 2. Notice we have parallel lines, we have transversals, and we're looking for the measure of angle 2. So let's start with angles on a line, and we have this 94, So we can find the angle right next to it on the same straight line. We know they're supplementary, so 180 minus 94 gives us 86. Now, since we have parallel lines cut by a transversal, what we can look at next are alternate interior. So if this is 86, it's alternate interior with this guy, and alternate interior angles are equal, so that must also be 86. We're going to use our theorem from up here, which says the measure of all three angles in a triangle sum to 180. So to find this missing angle, we're going to add these two guys, 86 and 57, and that's going to give us 143. Subtract that from 180. That's going to give us 37. And now finally, to find the missing angle at 2, these two angles lie in a line, so they're supplementary. So to find this missing angle, we're going to subtract this from 180. So 180 minus 37 gives us 143. So the measure of angle 2 is 143 degrees. Okay, on to exercise 3. We're going to find missing angles 3 and 4. So we have these two parallel lines. If you want, you can extend this parallel line out, but remember, it doesn't mean that 94 is cut in half or being bisected, so don't assume that. So we can start with the fact that 94 and the guy right next to it on the inside of the triangle are supplementary. They lie in a straight line, so they have to add up to 180. So to find this guy right here, we're going to do 180 minus 94, and that's going to give us 86. Okay, next step. Well, if you extend this guy out, which you're allowed to do, remember these two are parallel. And I have a transversal. If you notice, I have a pair of alternate interior with 46 and 3. Alternate interior angles are equal, so the measure of angle 3 must be 46. So there's one of our answers. And now we have to find the measure of angle 4. So using our theorem from the top of the page, all three angles in a triangle must sum to 180. So to find the missing angle in the triangle, we're going to do 86 plus 46. And that's going to give us 132. Subtract that from 180, and that's going to give us a 48. So the measure of angle 4 is 48 degrees. Okay, the last problem I am going to help you start, and then you are going to find the measure of angle 6 on your own. So if you look at this bottom figure, it's a triangle, and how many degrees in a triangle? Well, 180. So we're going to add up 68 and 58. And that gives us 126. Subtract that from 180. And that's going to give us 54. So there's a measure of angle 5. It's 54 degrees. On your own, you are going to see if you can finish this off and find the measure of angle 6. And your answer for that should be 39 when you finish. Okay, we're going to turn the page. We're going to do some word problems involving the triangle sum theorem. Number 5 says the degree measures of the angles of a triangle are x, 3x, and 5x minus 54. Find the value of x. Well, from our triangle sum theorem, it says all three angles of a triangle sum to 180. So we're going to add these together. Set them equal to 180. We're going to combine like terms. Don't forget there's a 1 here, so 1, a 3, and a 5 gives us a 9x. Minus 54 equals 180. We're going to bring the 54 to the other side by adding it. So 9x equals 234. To finish this off and solve for x, we're going to divide by 9. And x comes out to be 26. And they asked us to solve for x, and we are finished. Problem number 6. In triangle ABC, the measure of angle B is 21 less than 4 times the measure of A. Measure of C is 1 more than 5 times the measure of angle A. Find the measure in degrees of each angle of triangle ABC. If you would like, you could draw a triangle, draw a diagram for this. It doesn't matter where you label vertices A, B, and C. Okay, B is 21 less than 4 times A. Let's call A X. Well, how do you say 21 less than this? It would be X minus 21. 4 times A. So we're going to put a 4 in front. So it's 21 less than 4 times what A was. The measure of angle C is 1 more than 5 times A. 1 more than this. 5 times A. Okay, you are going to finish this one on your own. You're going to use the triangle sum theorem. You're going to add these together. You're going to find x. And when you're done, you should get x equals 20. Now, I asked you to find the measure of the degrees of each angle. So you have to find the measure of angle A, measure of angle B, and measure of angle C. And the way you're going to do that, once you get your x value, you're going to substitute it back in for A for the x. You're going to substitute it back in for the x for B and solve for B. Substitute the 20 in here for the x and solve for C. Okay, final problem we're going to omit for now because we haven't dealt with x squared yet. So we're going to omit that one for now. And we're on to the homework.